Hi students, good evening. So today we are going to look at the remaining type of numericals based on the mirror equation. Okay, see, we have been taking some time to cover this chapter, obviously because in our 12th syllabus, right, we have only after ray optics, we have wave optics, then semiconductors and communication system, which means we have only after these two more chapters. That is the reason why we are taking it a little bit slow. Okay, and also because it is a high weightage chapter, right, it's good to cover this in detail. Okay, so from NEET or JE point of view, it will be important that we'll cover this topic in detail. Okay, so what we were doing so far is we were looking at solving questions based on the uh, mirror equation and magnification formula for the mirror. Okay, so particularly in case of the spherical mirrors. Okay, so just to recall, right, we should not forget these formulae because they are like the bloodline for solving questions in this. So what is the mirror equation for spherical mirrors, right? What is the equation? 1 by v plus 1 by u is equal to what? 1 by f. This is the mirror equation. And magnification will be called as what? Lateral or transverse magnification will be what? Height of the image by height of the object. That will be equal to what? Minus v by u. What is the magnification? So in using these equations, right, what we should keep in mind? We should keep in mind that we have to follow the sign convention part. Okay, so today we'll begin the discussion with the concept of power of a mirror. Now power is a very what should I say, we should not say it as a generic word, but the context in which the power is talked about is if you have, think about it, a convex mirror is what? Diverging. A concave mirror is what? Converging. So power is supposed to indicate either the ability of that concave mirror to converge, because concave mirror, what it does, it will converge. The ability of that concave mirror to converge the rays, or in case of the convex, the ability of the convex to diverge the rays. Okay, that is the way in which we will talk about the power. Okay, when we go to the lenses, right, we will see what are some of the practical applications of this power also. Like one typical example, I am sure you would have studied this in our 10th standard. What is it? Like if you are trying to correct the eye defect, whether it is the myopia or hypermetropia, you will be using what? The corrective lens. So corrective lens, what will be the nature of the corrective lens? All these things you would have studied. We will also anyway study this, but strictly in the syllabus, right, we don't have the eye defects. Eye and eye defects, that part is not there in the 12th syllabus, but we would anyway just take a look at in terms of how the corrective lenses will actually be designed. But there we'll talk about the significance of power of a lens, because the power of lens will be correlating to how much eye defect you are having. Okay, so we'll talk about it over there, but here look at it now. See, think about a concave mirror. So you are sending a parallel beam of rays. It is converging to, say, a point over here. Okay, so this is maybe this is some distance. What will be this distance? By the way, it is what? The focal length, isn't it? What is this distance going to be? Focal length. When you measure from pole to principal focus, right, what is the length called as? Focal length. Now think about another lens. So I'll just draw one more, sorry, not lens, mirror. Okay, I'll draw one more mirror over here. Okay, I'll draw one more mirror. So this is also concave. Diagram might not come really proper, but think about it. This is also concave. Now imagine if this second mirror I am putting there is converging the rays to a point over here, to where the second mirror will actually converge the rays. It will converge to its own focal point, right? So let us call it as what? F dash. Now what you see is This length is higher, huh? What is this? This length is higher because the focal length of that second mirror you are putting here is what? Higher. So what you observe is when a parallel beam of rays are coming, the first mirror, the original mirror that is there, is able to converge the rays to a large extent because the rays are converging to closer distances, they are converging. Whereas the second mirror we put right, it is converging not so much because the rays are converging to a farther point. So the concept is we can link the converging power of a mirror to the focal length. How it will be linked? It will be reciprocal. So the relation will be what? It will be reciprocal. So we measure power of a mirror as simply the reciprocal of focal length of the mirror. That is how the power concept has evolved. Okay, so up to which point the rays are getting converged. If it is able to converge to a point closer to the mirror means what? Its converging power is actually high, like that. Okay, so how do we measure the power of the mirror? It will be simply measured as the reciprocal of the focal length. Okay, and in terms of the unit, right, if you take the focal length in meter, obviously the power should be coming in terms of what? Meter inverse. Okay, so which we will be calling as what? Diopter. Now when we talk about the convex mirror is supposed to do what? Diverge. So here also we see if the focal length is lesser means what? The amount of divergence will be more. Same, the power will be what? For the convex mirror or concave mirror, power formula is same. What is it? Reciprocal of the focal length. Okay, the only thing is, we may not be able to expect questions on this, but just keep one thing in mind. When we go to the lens discussion, right, there we will talk about combination of lenses and mirrors. There we will use this power concept, but otherwise we may not expect a straight question like in a 10th stand and all that, right? You will be even having questions like this. They will say, okay, look at this question. No, they will say there is a concave mirror of focal length 20 centimeter. What is the power of the mirror? Like that you will have questions, but here we may not expect questions like that. In which context we are going to use the power of mirror? Remember, when we complete the discussion about the lenses, right, after that we will talk about the combination of a lens and a mirror. We'll talk about the combination of a lens and mirror. Okay, there we will be bringing in this concept of power discussion. But here anyway, since we got this question, look at it now. What is it? Concave mirror has got a focal length of 20 centimeter. What is the power of the mirror? Now the only thing here you have to be careful is, if the power value has to come in the diopter, right, then your focal length must be changed into the SI unit, which is meter. We cannot straight away take 20 centimeter. We should first convert this into what? Meters. Okay, so look at this, guys. What is it that we are going to do? This is what? A concave. So as per the sign convention, we will have to take the focal length as what? We will have to take the focal length as what? Negative. So minus 20 centimeter, and we cannot have it in centimeters if you are looking to get the power in diopter. So what you have to do? Minus 20 divide by 100. We will change it into what? Meter. Okay, so 5. So what is it? Minus 1 by 5 meter. Okay, so this is what is the focal length. Then what is the power formula? Reciprocal of focal length means what? 1 by minus 1 by 5 meter. So what is it? Minus 5d. So what is the symbol we use for the diopter? It is what? Capital D. Okay, guys. So here maybe one thing we can just mark it. So if you talk about the concave, so as per the sign convention, right, the focal length is taken as what? Negative, which means power will be what? Negative for the concave. What about the convex story? Focal length we are taking it as what? As per the sign convention, positive. So power also will be what? Positive. Okay. Okay, guys. Now I'll ask you one simple theoretical question. So we talked about the concave and convex. If I ask you this, what will be the power? What will be the power of a plane mirror? What will be the power of a plane mirror? A plane mirror, right? What will be the focal length of the plane mirror? Think about it. So we are incidenting, this is the plane mirror. We are incidenting parallel rays. What will happen to the parallel beam of rays? when you incident normally on that plane mirror, what will happen to them? They will just, I'll just change the color and then show it to you. What will happen to the plane mirror when we are incidenting a parallel beam of rays? They would just reflect back in the same direction, right? Means what is the understanding we'll have when these reflected rays which are parallel, we'll say they are going to be meeting at the infinity, right? So which means what? The focal length. So for a plane mirror, we'll take the focal length as what? Infinity. For a plane mirror, we'll take the focal length as what? Infinity. Okay. So now just go by the formula. What is the power formula? Power is equal to what? 1 by focal length, means 1 by infinity. What is 1 by infinity, guys? 0. So theoretically, if you want to talk about the power of a plane mirror, right, what is it that we will have? We'll take it as what? 0. Okay. So this is about the discussion of the power. And as I said, right, here, in even board level or forget about even NEET and JEE level. Okay, so board level also, you may not be able to expect this straight formula question on the power. Okay, because it is a very basic idea. But the thing is, we should not just omit and move on. As I said, right, we are going to see the applications of this when we go to the combination of the lens and mirror concept. Okay, now we will get into the another important aspect with regard to the problems on these mirrors. Remember, in the case of the plane mirror, right, what is it that we have talked about? We talked about the image velocity. What is the relation between the image velocity and the object velocity? So I am just trying to recall. So if you have a plane mirror, remember guys, if you have a plane mirror, right, we have the object and we will have the image. Image will be on the other side of the mirror, correct? So remember, what are the two things that we said? The velocity component, which is along the perpendicular to the plane. So this is the plane, right? This is the plane mirror. So the velocity component perpendicular to the mirror will be what? In opposite direction. Means, look at this. No, this is V perpendicular for the object. This is what? V perpendicular for the image. So both will be in opposite directions. Whereas the velocity component parallel to the mirror for both of them, they will be what? Same. So we should not forget the things that we discussed before. If you have a plane mirror, we are moving an object with respect to plane mirror. Moving means not like always we are going to move along the perpendicular line or the normal line. We can move it any way. If we are moving in any direction means we are going to have two components of velocity. One is what? The component of velocity which is in this normal to the plane direction or perpendicular to the plane direction. There what happens? The components of velocity of the image and object will be equal in terms of magnitude but opposite in terms of direction. But what about the case of the parallel components of velocity? You take the velocity component parallel to the mirror, then both the components will be what? Same. So these things, we have derived them, but you need to at least remember the final result. Then, if there is a question coming on that, right, we will be able to answer it. Okay, guys. So this is what we discussed in the case of the plane mirror. Okay. Now let us come to the case of the spherical mirrors. So here we are going to talk about the relation between what? The relation between the velocity of the object and the velocity of the image. Okay, so here also we are going to divide the velocity into two parts. We'll talk about the velocity component along the principal axis. So we'll look at it as what? Two cases. First case, what are we going to discuss? We'll discuss about the relation between the component of velocity of the object and component of velocity of the image. In which direction? In the direction of the principal axis, or we'll say along the principal axis. Okay, so think about it. So where is the object going to be? It will be at a distance u. That is what is our object distance. Where the image is going to be, so don't bother about whether the image is really on the left side or right side, because anyway the sign convention will take care of it. If the image is the left side means what? V will be negative. If the image is right side means what? V will be positive. The sign of the V will take care of it. Here don't bother about, because I am showing in the diagram V to be on the left side. Don't think that the derivation is only for this particular case. The sign value will take care of it. Okay. Now let us look at it. If you talk about the component of velocity along the principal axis, that is related to what? The change in the value of u, correct? Because u represents distance from the principal axis. The rate at which the u is changing, it represents what? The velocity component of the object along the principal axis. Same way for the image, the rate at which the v value is changing, because v represents what? Distance of the image from the pole. So the rate at which the v is changing, it will represent what? The component of the image velocity along the principal axis. So now our task is what? To relate the component of velocity of the image along the principal axis to the component of velocity of the object along the principal axis. For that, you know what we are going to start with. We will start with, because we have only one equation. What is it? Two equations actually. Okay. So one is our mirror equation. Second equation is what? The magnification. What is the magnification? Minus v by u. So magnification represents what? It represents the height of the image to the height of the object. Now look at this equation. 1 by v plus 1 by u is equal to what? 1 by f. What is equation? 1 by v plus 1 by u is equal to 1 by f. This is our mirror equation. Take a derivative. Take a derivative with respect to time. So we will take a derivative of this equation. 1 by v plus 1 by u is equal to what? Right side also we have to take a derivative. Now for a given mirror is not changing. Focal length is constant. Means here on the RHS it is like what? We are taking the derivative of constant. What will be the derivative of constant? 0. So RHS is becoming what? 0. Now look at the LHS part. No, it is like what? Derivative of v power minus 1 plus derivative of u power minus 1. The total value is what? 0. Okay, so what are we doing? We are simply taking the mirror equation and taking the derivative of that with respect to time. From there, you know what we are going to get? We are going to get the relation between the rate of change of u value and rate of change of v value. Okay, so look at this, guys. What is it? This is like what? Derivative of x power n. Derivative of x power n. What is it? N into x power n minus 1 into dx by dt, because the derivative is with respect to time. Okay, then second term is what? It is the derivative, same type, n into u power minus 1 du by dt. The total value is what? 0. Okay, so this is like what? V power minus 1 means what? V power minus 2. Okay, so what is it? This is minus 1 is there, means what? Minus 1 by v square into dv by dt minus 1 by u square. Same way, u power minus 2 means what? You can write it as u square in the denominator, minus 1 by u square into du by dt. Guys, you know, you can parallelly work it out so that you will not miss out a point. We are not doing much. All that we are doing is what? Taking the mirror equation, then do the derivative. That's it. Okay, so we are going to get an interesting relation between the rate of change of the v value and rate of change of the u value. So we got it. We are there almost. Okay, so what is it now? The final step. So look at this, guys. So if you take one of the term to the other side, right, what we'll have? Minus 1 by v square into dv by dt. This we are keeping on the left side only. That will take it to the right side. It will become what? Plus du by dt. Now we are looking at the image velocity, right? What is the image velocity? It's not the total image velocity. What is this? The image velocity along the principal axis. dv by dt is what? What is dv by dt, guys? It is representing what? The image velocity along principal axis. Du by dt, it represents what? The object velocity along principal axis. Okay, now dv by dt is equal to what? We will take the minus v square to the other side. It will go to the numerator. minus v square by u square into du by dt. This is a very important formula, guys. What is it? dv by dt is equal to what? Minus v square by u square into du by dt. Okay. Now, in some textbooks, right, you might find that this is the relation between the total velocities of the image and the object. So what you have to be very clear with, this is not the relation between the total velocities of the image and object. What is this? This is the relation between what? The object velocity component along the principal axis and image velocity component along the principal axis. Okay, so what is the formula? Maybe you can just make a note of the formula. What is the formula? dv by dt. What is the dv by dt? What is this dv by dt? It is the image velocity along the principal axis is equal to what? Minus v square by u square into du by dt. What is du by dt? The object velocity along the principal axis. So look at this. The velocity of image along the principal axis will be equal to what? Minus v square by u square into the object velocity along the principal axis. Here we can also express this formula in terms of the magnification factor at a particular instant, right? See, here the velocities are related based upon what is the value of v and what is the value of u at that particular instant. The image velocity and the object velocity components along the principal axis, right? They are related to what? The v value and u value at that given instant. So we can also express, remember, what is the magnification factor value? Minus v by u. For a mirror, what is the magnification factor? Minus v by u. Now square it. M square is equal to what? V square by u square, right? So in place of the v square by u square, what we can keep? M square. So look at this, guys. Velocity of the image along the principal axis will be equal to what? Minus m square into velocity of the object along the principal axis. This m will be what? Magnification factor at that instant. That will be what? Magnification factor is nothing but minus v by u. So either you remember this or you remember this. Okay. So guys, what is the final result we have? The image velocity along the principal axis is equal to what? Minus v square by u square into the object velocity along the principal axis, or we can say vi is equal to what? Minus m square into vo. So this m represents what? Magnification at that given instant. Magnification at that particular given instant. Okay. So this is what is the relation in terms of the component of velocities along the principal axis. Okay guys. Now we will go to the second part. See, I am showing the derivation so that we will understand exactly how these things are coming. Otherwise we could have even looked at them like a formula and then moved on. But the point is, if you don't understand how they are coming, right, it will not make much sense to remember the formula as such. Okay. So because it will be obviously a lot more confusing how it is coming and things like that. Okay. So now we are talking about the relation between the velocity components of the image and object, which will be perpendicular to the principal axis. So this is the principal axis. Now we are looking at what? The relation between the velocity components of the object and the image. In which direction? Perpendicular to the principal axis. Now you might think, is it like, the object is going up and the image is going down? We don't know. That is going to be determined based upon the final values that will arrive by using the sign convention. Here we are just trying to depict it. Okay. When we say the velocity component perpendicular to the principal axis, means like that, it will be perpendicular. Okay. Now if you look at it, right, think about it. If the object is at a distance x from the principal axis, this is like what? This is like our what we can say, height of the object. If we consider the object to be what? Like a point object, isn't it? So because heights, how do you measure? You will measure them along the normal to principal axis, right? Similarly, if the image is at a distance y, the y may be in this direction also, we don't know yet. Okay, we are just taking one sample representation, that is it. Okay, so the Y value represents what? It represents the height of image, because heights generally how do we measure? We will measure perpendicular to the principal axis. Now look at this. Now we have a important formula. What is it? At a given position, because here remember this u value is not changing when we are talking about the component of velocity perpendicular to the principal axis, right? We are assuming that the u is not changing. Similarly here the v is also what? Not changing. Means this magnification factor will be what? Constant, because what is after all magnification factor? Minus v by u, right? This will be what? It will be a constant. But what is the magnification factor? It is what? Height of the image by height of the object. From here what we'll have? Y is equal to mx. So here y represents what? That distance of that image from the principal axis. X represents what? Distance of the object from the principal axis. Now you tell me, what is this velocity of the image perpendicular to the principal axis represented by dy by dt only? No, the rate at which the y value is changing. What is the velocity of the object perpendicular to the principal axis represented by dx by dt? The rate at which this x value is changing, correct or not? So as the x is changing, the object will be moving in the direction. So that is what is the object velocity perpendicular to the principal axis. What is it? Rate of change of y value is what? The image velocity perpendicular to principal axis. Rate of change of x is what? The object velocity perpendicular to principal axis. Now all we will do is look at this. Now we already have a relation, y is equal to mx. Just take a derivative of this. Take a derivative with respect to time. So in this you have to keep one thing in mind. What is it? M is a constant. Why M is a constant? We are looking at the movement of the object perpendicular to principal axis. Means what? M is fixed. So look at this. You take a derivative. dy by dt is equal to what? Right side M is a constant. M into dx by dt, which is what? Velocity of the image is equal to M into velocity of the object. These velocities are what? They're what? They're perpendicular to the principal axis. So guys, what is the relation? The components of velocity perpendicular to the principal axis, right? What is the relation? Vi is equal to what? M times of Vo. Okay. So maybe we have done the derivation. Now you need to remember this result, because while solving problems, right, we'll be using it. Okay. So what are the two relations? The velocity relation with the components of velocity parallel to the principal axis. What is the formula there? Vi is equal to what? Minus m square into Vo. This is what? Parallel to the axis component. What is the relation in terms of the perpendicular to axis component? Vi is equal to what? M into Vo. Okay. So now we'll go and look at a question. So look at this one. So I mean, this is a straight formula question, guys. Already we discussed about it. You'll just have to use the formula and get the answer. I'll wait for some time. I'll read the question, give you guys some hint, and then I am going to wait. Focal length of the mirror shown in the figure is what? 20 centimeter. Obviously, what is the mirror? It is the, what is it? It's a concave, right? Means as per the sign convention, we are going to take it as what? Negative. Focal length, we are going to pick it as what? Negative. Okay. Where is the object? Object is kept 30 centimeter in front of the mirror. Find image position and also its velocity. Remember guys, what they have given? They have given the object velocity. Object is having how much velocity? 5 millimeter per second, at making an angle with the principal axis. See, the object is making an angle with the principal axis. We will go step by step. First, what they're asking, find the image position. I think this is a pretty straightforward thing. Guys, I'll wait for some time. You can find the image position and tell me what is it that we are going to do for this particular configuration. We know the u value. What is the object distance? It will be what? Minus 30 centimeters. Why? Because always distances in the left direction, we will take it as what? Negative. Always the object distance will be what? Negative. Okay. What about the focal length? Minus 20. Why minus 20? Because it is a concave. Now we are supposed to find the v value. What is the formula? What is the formula? I showed you some shortcut, that derived formula. If you are able to remember them, that is fine. If you are not able to remember, you will always remember this one. What is it? The mirror equation. 1 by v plus 1 by u is equal to what? 1 by f. So from here, 1 by V is equal to 1 by F minus 1 by U. 1 by F means what? F is minus 20 minus of 1 by minus 30. Okay guys, so what is this? This becomes plus. So now it's like what? 1 by 30 minus 1 by 20. LCM of the denominators is what? 60. So we got it. So 1 by V is equal to what? Minus 1 by 60. Means what is the V value guys? I'm expecting answers. V will be equal to what? What is the V value? V will be equal to how much? Okay. So not many of you are responding in terms of answer. Guys, this is a straightforward. No, we didn't do much. This is still the 10th standard level stuff. Finding the image location. Okay. So you have to confirm whether you're able to get it or not. What is the V value we are going to get? We will get the V value as what? Minus 60. V will come as what? Minus 60. Okay. Now comes the real part of the question. Okay. So I'm waiting for your answers guys. Maybe once you get it, you can confirm. So look at this now. The object velocity is what? 5 millimeter per second, making an angle of 37 degrees. Remember guys, trigonometric common values, right? This 37 is also one of the common angle. 37 and 53. Cos 37 will be 4 by 5 and sin 37 will be 3 by 5. The complementary angles will be what? 53, because 37 plus 53 is what? It will be 90 complementary angle. So cos 53 will be what? 3 by 5 and sin 53 will be what? 4 by 5. I'm sure you know these angle values, but if you are not, maybe at least now you can make a note of it. These are also some common angles that people keep giving us. Okay, because the right angle triangle with the sides 3, 4 and hypotenuse 5, that is a very common right angle triangle, right? So now let us come to here. So we have to find the component along the V object parallel. This is what parallel. What is it? 5 millimeter per second into, this is what? Cos 37. What is cos 37 means? What is cos 37? 4 by 5. Huh? So we'll get 4 by 5. So 5 is cancelled. What is it? 4 millimeter per second. Okay. Now what about the component perpendicular to the principal axis? It will be what? Sin 37. So like, you know, V cos theta, V sin theta. Okay. So what is it? 5 millimeter per second into sin 37. Sin 37 is what? 3 by 5. So 5 is cancelled. What is it guys? 3 millimeter per second. It's just resolving. Okay, we are just, the only thing is, normally we would have been more comfortable, but the only thing is here, you know, we have some angles that some of us might be little bit familiar, some of us might not be. Okay, so I'm just erasing this part so that I can draw the values correctly. Okay, I'll just now represent the values only. Okay guys, so we got how those values will be coming. So V parallel along the principal axis, what is it? 4 millimeter per second. What about the V perpendicular? 3 millimeter per second. Okay, how did we get it? Just resolve the velocity into the components. Okay, now let us come to the very important part. What is it guys? We have to talk about the what? We have to talk about the relation between the image velocity and the object velocity. For that already we have a formula, right? What is it? Along the principal axis means, what is the formula guys? Image velocity is equal to what? Minus m square into v naught, or object velocity, correct? So here we should first get m. What is m? Minus v by u. V is what? Minus 60. U is what? Minus 30. So minus 60, so it's what? So m will be minus 2. Means m square is what? 4. M is what guys? Minus 2. M square will be what? 4. Now look at this. Here, if you take the right side to be the positive, if you take the right side, this object velocity component will be what? Positive, right? Now look at what is the image velocity component. Minus m square. M square is what? 4 into object. What is the object velocity? 4 millimeter per second. Totally what is it coming, guys? Minus 16 millimeter per second it is coming. Which means what? If you look at the image, here is the image form. Minus 60 means it will be some double the distance. It will be what? Double the distance, right? It will be here. Here, what about the component of velocity parallel to the principal axis? Right side you take positive means this is coming negative. Means what? The component parallel to the principal axis will be exactly opposite direction. What is the value? 16 millimeter per second. What is the value there? It will be what? 16 millimeter per second. That is what is the significance of the minus. We take the right side positive means minus represents what? Left side. Okay. So that is what is the component of the velocity parallel to the principal axis. Okay guys. So we are just going on with the formulae. That is the reason why we said we will remember the formula, right? Every time we cannot keep on deriving them. Okay. Now let us look at the component of the velocity perpendicular to the axis. What is the relation there? Vi is simply equal to what? M into Vo. Now look at it. Vi is equal to M is what? M is what? Minus 2. Minus 2 into, let us say we take the upward as positive. We are taking the upward as what? Positive. So what about the object velocity component? We'll take it as positive here. So totally what is it coming as? Minus 6 millimeter per second, like that it is coming. Which means what? We took upward positive. This value is coming negative means what? The image will have a component of velocity perpendicular to the principal axis, which will be in the downward direction. And what about the value, guys? It will be what? 6 millimeter per second. So step by step we are able to solve means we will be able to get the answers for any type of question. So here, right, the only thing is we have to remember these formulae. If you are able to remember the formula means we will be able to answer this particular type of questions. So look at this, guys. So we have the image at how much distance from the pole? It is a distance of 60 centimeter. That's what we got, right? V is coming as what? Minus 60 means on the front side of the mirror only it will be there 60 centimeters. Okay, so this is where the image is there. What is the component of the velocity parallel to the principal axis? It is 16 millimeter per second towards the left. What about the perpendicular? 6 millimeter per second down. So overall image velocity means it will be the resultant of the two. Here they are not asking. Okay, I mean if they are asking what is the overall direction, then we have to tell what is the theta value and all that. Here they are just asking us what is the image velocity. Means what? We have the component parallel to the principal axis and component perpendicular. If you have to tell what is the total image velocity, means what? We have to take the resultant of them, right, which is what? Root of 16 square plus 6 square. Okay, so if you have to tell the answer means what is it going to be? Root of 16 square plus 6 square. Okay guys, so that is what will be the total image velocity. Here we don't need to mention what is the angle and all that, because they are not asking us that question. They are not asking what is the orientation of the image velocity and all that. They are not asking. Okay guys, so here two important things are. What are the two important things? One is the formula for the velocity components relation parallel to the principal axis or along the principal axis. What is it? Vi, image component, is equal to what? Minus m square into Vo. Component perpendicular to the axis, what is it? Vi is equal to what? M into Vo. These two formulae remember means on these image velocity, object velocity form questions, we will be able to answer any type of question that can come. Okay guys, so this is about the velocity relations when it comes to the mirrors, spherical mirrors. Already we have seen in the case of the plane mirror. Now we are covering the spherical mirror part. Okay, now we will move on to the last segment. We talked about the length of the image or size of the image of an object when we keep the object along the principal axis. Already I think in session 5 we have solved it. Remember what we said, guys? You take the mirror, whether it is the concave mirror or convex mirror. We are keeping an object AB along the principal axis. Remember what we said? We have to find where is the image location for A. Let us call it as what? A dash. We have to find where is the image location for B. Let us call it as what? B dash. Now, if AB, this is like a rod or something, that is our object. The images of all the points of that object will be spread between our A dash and B dash. Means if you find what is the separation, if you find what is the separation between, separation means what is the distance or gap between A dash and B dash, that represents what? That represents the, what it represents? It represents the length or size of the image when we are keeping it along the principal axis. But even in, I think, one of the previous year NEET also we got this question. Okay, so this is the general case. This is a general case. Okay, but the question that I am going to talk about now, or the case, is the size of the image when the object is a short object. So we are going to derive a formula here. If you remember the formula, means you can answer the question. What is it? Here the object AB we are taking, right, is supposed to be a short object. The object is what? It is a short object. Okay. Now, how are we going to relate the length of the image or the size of the image to the size of the object in this particular case? See, for a moment, forget that this is a AB object. Think of it like, okay, it is like a point object which is at a distance u from the pole. For a moment, just begin by assuming what? It is like a point object. Don't think that it is spread. Then if there is a point object at a distance u from the mirror, its image will be somewhere. Maybe it can be on the left side of the mirror, or it can be on the right side also. We don't know. It depends upon what is the position of the object with respect to mirror and what is the nature of the mirror also. Correct? So let us try and look at the relation between the u value and v value. What is the relation I am talking about? It is the relation that we have been talking about for a lot of time. What is it? The mirror equation. What is it? 1 by v plus 1 by u is equal to what? 1 by f. Okay. Now remember, when we did that image velocity component and object velocity component relation along the principal axis, what did we do? We have differentiated this particular equation. We took a derivative of the equation, right? Now we are going to do the same thing. Okay, so what are we going to do? Take derivative of the equation. What are we doing? We are taking the derivative of the equation. Okay, so if you take the derivative of the equation, maybe let us not do it one more time. Let us just look at the final result. Remember guys, what is the final result we have got? dv by dt. Remember, this is the final result. dv by dt is equal to what? Minus v square by u square. Otherwise, what we said, in place of v square by u square, we can also put m square. Correct? Minus v square by u square into du by dt. Remember guys, this is the relation we had. The rate at which the v value is changing, rate of change of v value, dv by dt is equal to what? Minus v square by u square into du by dt. Okay, using this, right, if we cancel the time derivative on both sides, then what we are going to get is dv will be equal to minus m square into du. So here we are saying differential change in the value of v will be equal to what? Minus m square into differential change in the value of u. So differential change in the value of v is equal to what? Minus m square. Same formula. All that we are doing is what? Taking out the derivative with respect to time. So it will give us what? A differential change in the value of v. dv is equal to what? Minus m square into du. Now look at this guys. If you take modulus on both sides, imagine what you will have. Modulus of dv is equal to what? You take a modulus of minus m square into du. What is this? Modulus means minus will not be there. So modulus of dV is equal to what? M square into modulus of dV. Now understand this carefully. Yeah? If it is a short object, can we say the spread of the object is going to be very small? It will not be, of course, differentially small. It will be very small. Okay. But as an extreme approximation, what we can think of it? We can think of it like that very, very small change in the value of u. It represents what? If you take a modulus means, because modulus means what? Whether it is a positive value, negative value, we are just looking at the length. Okay, absolute value. Okay. So modulus of du represents what? At that particular position, if that object has got a very small spread, then that small spread can be represented by what? Modulus of du. Same way, the image is formed somewhere. Here the modulus of dV can be representing what? It can be representing that small spread in the image, which means what? That represents what is the length of the image. Remember guys, this is a extreme approximation. That is what I'm saying. This is an extreme approximation. And is it practically possible? No, because always our objects will have some considerable spread. Will they have a spread of du? They will not have a spread of du. Okay. But you know what? These kind of questions will be true, or they will be valid when, if the distances you are measuring from the mirror, or all these uv values, let us say they are in terms of meters like that, and our object length is in terms of some millimeters. It's a very small. So when you look at meters and millimeters, it will be what? Very, very small. But nevertheless, it can never be that du. That is why I said what? It is an extreme approximation. So what is the relation we have, guys? If you take this dv as what? The length of the image is equal to what? M square into du is what? Length of the object. Okay, so what is the relation we are having? Length of the image. Length of the image is equal to what? M square into length of the object. We already took a modulus. We took a modulus, right? Okay, so this will be the, it's a straight formula. This will be the relation between what? It will be the relation between the length of the object and length of the image when the object is a short object. When the object is kept along the, so where is the object kept? Object is kept along the principal axis. Already we solved a question like this, but there what is it? The object has got some considerable length. In that case, what we will do, as I told, we will pick image of one edge of that object. We will pick the image of other edge of the object. Like we will find what is the image of A dash we will find. We will find where is the image of B, like B dash we will find. Then we are going to look at what is the gap or separation between A dash and B dash. Okay, that will give us what is the length or size of the image. That is one. If the object is a very, very small object, or in this case we call it as what? Short object. When this assumption will be valid, if the distances you are measuring are in terms of say meters. Distances means the v value, u value, they are in terms of meter range, and our size of the object is in like typical millimeters, etc. This assumption or this formula can be used in that particular case. Okay, so what is the formula we have to look, guys? Length of the image is equal to what? Simply m square into length of the object. There is an easy way to remember it. What is it? Look at the velocity component formula between the perpendicular image velocity component and perpendicular object velocity component. The difference is there we will get what? dv by dt is equal to minus m square into du by dt. Here we are taking a modulus. That's why the minus will not be, because length means what? We'll take the absolute value. Length means we'll take the absolute value. Okay guys, now let us see who can answer this question. It's a straight formula question. Now look at this. A small object AB of size 1 millimeter. Look at this. What is the object size? 1 millimeter. This is what I was talking about. The object size will be very small. Is kept along the principal axis at a distance of 40 centimeter from the concave mirror of focal length 30 centimeters shown. What is the size of its image. What they're asking, guys, they're asking what is the size of the image. So here, do we have the formula? What is it? The length or size of image is equal to what? M square into length or size of object, isn't it? So for this we should know what is M square. M square means what? What is M square, guys? M square means what? V square by U square, right? Because M is equal to minus V by U. We know U, but we don't know V. So first step of the problem will be what? To find the V value. So look at this, guys. What is the U? Will be what? Minus 40. Why minus 40? Because our convention says what? We will keep the objects in front of mirror. So the distance will be measured from the pole. We are measuring the distance to the left. So U will be what? Negative. What about the focal length? It's a concave mirror. So focal length will be what? Negative. Now what is the equation we have? Only mirror equation. 1 by V plus 1 by U is equal to 1 by F. 1 by V. What is U? Minus 40. Just substitute. What is F? Minus 30. So check it, guys. Can you tell me what is the V value? So 1 by V will be coming as what? This minus 1 by 40. Let us take it to the right side. It will become plus. So 1 by 40 minus 1 by 30. What is the LCM? 120. So 3 minus 4, which is equal to what? Minus 1 by 120. Guys, which means what is the V value? V will be equal to what? Minus 120 centimeters. What is the V value? V will be equal to how much? It will be what? Minus 120 centimeters. Okay. So we got the V value. Now what is the next step? We have to find what is the size of the image. Here they are not asking us where the image is. They are asking us what is the size of the image. Means we will try to get the M. No, M is what? Minus V by U, right? Minus V is minus 120 by U is what? Minus 40. So what is this? Minus is there. Minus 3 will come. M is what? Minus 3. But we don't need M. We need M square. What is M square? 9. M square is what, guys? 9. What is the relation? The length or size of image is equal to what? M square into length or size of object. So M square is 9 into what is the length of the object they gave us? 1 millimeter, right? So 9 into 1 millimeter. What is the value going to be? It will be how much, guys? 9 millimeter. So what is the answer for this question? Let us see if any one of you is able to get the answer. Guys, we have to start solving more and more problems. Okay. So what should be the answer for this question, guys? It will be what? 9 millimeters. That is the size or length of the image. It is for what? This formula is for what? We have to keep in mind. It is for the short object. Generally in questions, right, to make sure that we are comfortable in understanding, they will themselves mention like a short object AB, like that they will mention. In this question what they are mentioning? Small object AB, like that they will mention. Okay. Otherwise, what is the other hint I said? When the U value, V value are large, you can see here they are in terms of what? 40 centimeter. But what about the size of that object? 1 millimeter. You see, large difference. That is when we can make this assumption of the short object. Okay, guys. So this is what we have to cover in today's session, and with this, right, we have covered the mirror part. In the next session, right, we'll start with the idea of refraction, and from there we'll go into the devices which will work on the principle of refraction. Okay, guys, we'll see in the next session.